here, for example, 4C3, we have our givens, and in this problem, the problem statement says that we need to find the speed of the tug during this period of time, which means we need to find VA for this problem. And for B, it states to find the average value of the tension in the towing cable at this time. So that is T average of the cable. So the solution for this problem, we'll be going through the steps that we learned in class. The steps written out are: 1, to find the free body diagram; 2, to set up the coordinate system; 3, to write all forces in vector form; 4, to apply our equations. Okay, for step 1, we're going to have 2 free body diagrams, one that has the tension of the rope included and one where tension is the internal force. So for the one where it's the internal force, we'll have our 2 masses set up, mass A and mass B. Each one has a weight force on it pointing down, and each also has a normal force. There's no friction in this problem, so these are the only 2 forces acting on them if our cable is an internal force. And when you have the tension of the cable, have our 2 masses, here we have tension A and tension B. And these also have our weight forces and our normal forces. And that is it for what we need to find and the first step of this problem.
Alrighty, now that we have our step 1 done, our free body diagrams with our whole system and then our separate systems, you are going to want to set a coordinate system, which is our step 2. And to set a coordinate system, you can set it up however you want, but for me, I'm going to make upwards be the positive J direction and to the left be the positive I direction. And that is all you have to do for step 2. And that is finding your coordinate system.
So here we have weight forces for both boats A and B. Weight is always equal to mass times gravity and will always be in the negative J direction. Next is normal force, which is always perpendicular to the ground. Since normal force is unknown, it will be marked as NA and NB. Normal force is also in the positive J direction in this case. Finally, there is tension, which acts on both boat A and B together. These are also unknowns marked as TA and TB. TA will be facing in the negative I direction, and TB will face in the positive I direction.
Go. Now we will move on to step 4, which is to apply and assemble the equation we were given in class. By looking at the free body diagrams, we can see that there is conservation of linear momentum in both the J and I direction because the sum of the forces equals 0 for the whole entire system. Therefore, this part of the equation will cancel out to 0 and you're left with this. And rewriting that, it gets you mass A times the second velocity plus mass B times the second velocity of B minus the same thing, but for the first velocities of each. We will also have a relative speed for this, which is BA, and that is the winch speed. That is equal to your second velocity of B minus your second velocity of A. This will be equation 2, and the one above will be equation 1. We're then going to plug equation 2 into equation 1, which then simplifies down to 0 equals mass A times the second velocity of mass A plus mass B times the relative velocity plus the second velocity of A minus the first velocity of A times mass A plus mass B. That then continues to simplify down to 0 equals the second velocity of A times mass A plus mass B plus mass B times the relative velocity minus the first velocity of A times mass A plus mass B. Therefore, when you simplify for the second velocity of A, which is what we are trying to find in our problem, it simplifies down to your first velocity of A times mass A plus mass B minus your relative speed times mass B all over mass A plus mass B. That is our first part that we were trying to find. Our second part, we use the same equation above, except we're finding tension. So tension we will say is T, which replaces the F. And we will be using block A from our free body diagram. We'll be using this one here. So tension ends up being constant. So we're going to end up using the equation T average times the change in time equals mass A times the two velocities subtracted from each other for position 1 and 2. This simplifies down to T average times delta T is mass A times the second velocity minus mass A times the first velocity. And this second velocity for A is what we find up here. So then to find the average cable tension, we will have mass A times the second velocity minus mass A times the first velocity of A all over your delta T. And that is how you solve example 4C3.